Welcome to Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we're given a set G is the product of G1, we're given a group G, which is the product of some subgroup G1 with G2, so it's just a product of these two groups. We're also given that the greatest common divisor of the order of G1 and the order of G2 is 1, so they're relatively prime. We want to prove all subgroups of G are over the form H1 product H2, where H1 is a subgroup of G1 and H2 is a subgroup of G2. So this is going to come in two steps. First, knowing that all the subgroups are in fact contained in a subgroup of that form, and in fact the order of H1 divides the order of our subgroup, and the order of H2 divides the order of the subgroup H, and so they must be equal. So let's first consider the projection from G onto G1. So that's some homomorphism, the image of which will just be G1. Note, so this also will induce a homomorphism on H, which will give us some subgroup H1. This is really the subgroup, which is just all the elements on the left side of H, so we consider H a set of A, B, comma, C, D, etc. The left elements A, comma, C, comma, anything else will actually form a subgroup. This is H1. And the other projection for the right side, we'll call that H2. So note by an isomorphism theorem, the kernel of F, the induced homomorphism on H, the kernel of this induced homomorphism, which is only on H. So yeah, that kernel, the magnitude of H divided by the magnitude of that kernel will give us the magnitude of H1. This implies actually magnitude of H1 divides the magnitude of H. So similarly, we have the magnitude of H2 must divide the magnitude of H. And since G1 and G2 are relatively prime, H1 and H2, which have factors which divide G1 and G2 respectively, must also be relatively prime. So we must have H1 times H2 divides H. So we have our two key points, which is magnitude of H1 times magnitude of H2 divides magnitude of H. This is just the magnitude of H1 cross H2. And also H is a subgroup of H1 cross H2. But these two imply that, H, also note G is a finite group. So H is contained in H1 and H2, but it also has the same number of elements as H1 and H2. So it must be, in fact, all of H1 and H2. And so we have H equals the product of H1 and H2. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.